and welcome. Today we're going to talk about the Hunter BL505 Brake Lathe. A brake lathe is basically a machine that will turn something, in this case brake rotors, drums, and other parts of a vehicle, and literally cut a layer of very, very fine steel off the device. We're going to focus on three things today: a drum, a hubless rotor, and a hubbed rotor. Now the drum and the hubless rotor mount in a similar fashion. The hubbed rotor requires special adapters. And before we get started, always be sure to read all safety items. Be sure to read all service procedures before you do this. This is no way it compensates for you ignoring the service procedure. Read your books. Now, first, let's get familiar with the machine. As you can see, on top of the machine we have our adapters for our hubbed rotors, as well as the silencing pads and the belts used to cut drums. On the tool tray we have the wrench, the chuck, and the 3/8 drive key. Those are the only thing that stay on the tray when you're done. We also have the controls for the blades and the switch from drum, off, and disc. Make sure you select the right one when you're cutting. Then we have the power button, the speed, and the warning light for the drum bar, and the control to bring the blade in and out for the drum. Lastly, we have the shaft that mounts all of your adapters, rotor, and drum. Make sure it's secure before you start spinning it. Alright, now one of the first things I'm going to show you are the different types of drums and rotors that we have here in machining. A hubbed rotor looks like this. As you can see, it has a hub in the center where the wheel bearings go. On the back side, that's where the other bigger wheel bearing goes. There's a seal that would go there if it was on the vehicle, and when you do your brake station, you'll see what I'm talking about. Your hubbed rotor basically requires special adapters for it to go onto the machine. Your hubless rotor looks like this. It's a rotor with the centerpiece basically not there. The hub is missing. In fact, this mounts onto a hub on the vehicle. In most cases, your lug studs go right here. Some vehicles will have them installed, just depending on which make and model you're working on. And of course, this rotor right here is probably the most commonly used on a front-wheel drive vehicle. A brake drum looks like this. It literally is drum shape and fits onto a hub or axle. The drum gets machined on the inside, and you literally have to machine these with the right cage, or the cage will get in the way of the blade, and we'll discuss that here in a little bit. The actual tool to measure rotors is a micrometer. This measures how thin you can go. You go too thin, the rotor is trashed. However, a drum is actually what they call maximum diameter. Because you're machining the inside, you're literally making it wider. And a drum does have its own specs, usually written, as you can see here on this Honda. They'll tell you, and that's kind of hard to see, but maximum diameter. Because of this, this lets you know if this drum has been machined too many times, or for whatever reason is too wide, it is trash. So remember, rotors are minimum thickness, drums are maximum diameter. Now I'll get my cage, I'll put it in place. Now I'll remind you that any type of grease or dirt will actually make these a little difficult to slide. So if that happens, make sure you actually get a paper towel and clean these off. Reach over here, grab my hub, mount that together. Now I have all this space here. I'll actually reach up in here, get two spacers. Now you can actually grab as many as you need. In this case, I believe I only need two spacers. If you notice, this is just at the end of the threads. and I need either a different spacer, a little bigger one, or if I know how to use this properly. And if you look inside, there's an area that has no threads. And you have an area of threads. Basically, the inside of this has been widened to go over this if need be, which is the perfect type of nut that we have that will fit. If I were to use the other end, it would actually run out threads before it hits the end, so it wouldn't go over. Okay, I grab my wrench. Now, these are left-hand threads. That means I have to go to my left, counterclockwise to tighten. And I just go, that's it. I don't have to crank down. I'm not trying to use a lot of torque here. Just to snug it up. If I've done this properly, this whole piece should basically be steady and not moving. Then I need my bands. Now these prevent vibration. In a minute I'll show you what it looks like or what it sounds like without these bands being on. Make sure you're centered. I got different styles. I even have bands for very small, thin rotors too as well. Alright, now we're ready to cut. Now when cutting, one of the first things we want to do is actually adjust this piece right here. I'm going to take my wrench, loosen this, remove the pin right there. You don't have to remove that pin, but it depends on how much of adjustment you're moving. But you can if you want to. But really all I need to do is bring in my machine, and I want to center my rotor up to a imaginary point right here. Now as I do that, once I'm happy with where I have my rotor, my blades, everything else, I'll lock down my blades, and I'll make sure that my little tab is inside here. Can you see that right there? Okay. Now I'm almost ready to cut, but before I can do a real good cut, I'm going to have to machine the lips off. Now, these lips or ridges are on both sides of the rotor. Now they're kind of hard to see on camera, but there's a ridge right here. And that ridge, if my blade were to hit it, will instantly stop the machine and blow the breaker. To prevent that, I'm actually going to come in about halfway, just lightly touch, and then mainly machine out the ridges, then machine to my inside ridge or lip, and then start from my 0 point there and cut out. Now to show you how that works, this is going to get very loud here in a few minutes. But first, I have to turn on my machine. And then, I'm going to bring in my blades. My blade control is this lateral movement here. Now when I get about halfway in, I'm going to unlock one blade, bring it in, and all I want to do is just barely touch. I'll lock that down. I'll do the same thing for the other side. I'll lock that down. Okay, now I'm ready to cut off the ridges. Now I'll just back this blade out. Now, as I was cutting it back, I was actually going very slowly. You go too fast, you'll bog the machine down. Now I want to go all the way to the inside. That noise you're hearing is basically a very deep cut going into the ridges. It is somewhat normal, however, if it gets too loud, you want to go either slower or back up and see exactly where you're cutting, where you want to end it. In this case, I have just a little bit more to go and I'll clear it. As you can see, I'm almost done with my inside ridge. Okay. Now I'm ready to cut. What you see me do on one side, I'm going to do on the other side, and that's actually going to loosen this up right here. And I'm going to bring it in a few thousandths of an inch. Now the numbers are real faded, they're hard to see. You can see a 6 right there. There's my thousandths, so my zeros right there. I'm going to go in about, let's just say about 6 thousandths in. Lock that down. And I'm going to do the same for the other side. So now I did 6 thousandths on one side, 6 thousandths on the other side. That is 12 thousandths total. All I have left to do is move my cutting head back and make sure I select the right speed. Now the speed I want to select depends. This is for a slow final cut. This is for a fast. You know you're going to cut it more than once. Now listen very carefully. For the sake of class, you're always going to cut on course. But for real life vehicles, you're going to cut on course to start with and then go down to one for your final cut. We today are going to do both. So I know that I'm probably going to do more than one cut. I'm going to move this all the way to fast. Make sure this light is turned off. If it's not, I got to make sure I turn my handle in and bring in my blade. Okay, so my speed is set. Next thing is to actually move the controller to disk. I am fast forwarding this, but remember my blades are locked and I'm cutting off a layer on fast speed. Okay, now the cutting is done, but we're not done yet. I gotta stop the machine from making the blades go back any further. Next, I have to look at my rotor and see if all of the old rotor surface has been taken care of. As you can see, there's still rust. So I'm going to repeat what I just did on a fast cut. Basically, I bring in my arm. Now, I don't have to readjust my blades or anything else, not yet. Not until I bring my blades all the way in. As I bring the blade in, I'm going a little deeper. Now, always remember to lock these blades. If you don't, it's not going to cut right. I'll go back to my controller, put it back on rotor. Keep doing this until both surfaces are completely free of the old rust and imperfections. However, in the customer case, if we have a customer vehicle, where actually we do a slow final cut, which is what I'm going to show you here, because I believe I can take all of this with my last cutting. So I'll go ahead and get the machine set up again to do that, and all you do basically is you do exactly the same thing you were going to do, except that you put it on a slow cut. Okay, we are now done cutting on this rotor. I'll go ahead and stop the blades. I'll back them up a little bit, but I'm not completely done with the actual rotor itself. I want to finish it. Now for now, I'll go ahead and turn it off so you can actually see that the rotor is nice and machined. But the problem with this cut is that if you look at it very, very closely, closer than this camera can get to it, it looks like a record player. And it has one line going all the way across it. Now that would actually promote noise and promote vibration, in which we want to avoid. So we want a non-directional finish. There are different ways to do this. You can use sandpaper while it's rotating, or in this case, we're going to use a power tool. So we're actually going to use a grinder that has a sandpaper type of material here. Again, you can use a sandpaper if you want to. I'll turn it on, and quite literally, and that's all I would do. You notice the finish now has markings that go up and down it to help prevent noise. I didn't grind so much away that I'm actually trying to make my own craters in there. I'm grinding just enough to scratch the surface to help prevent noise. Now, take off my band. Remember, we are right, in this case, to loose, left to tighten. Again, I'll grab it by the chuck, like this. Now, this rotor is ready to go on the vehicle back to the customer for him to have a nice, smooth drive. Now, one of the next things that we're going to focus on is a hub rotor. The hub rotor cuts the same way a hubless rotor does. However, the mounting is different. Let me demonstrate. Okay, so now we're going to pick the right adapters for our hub rotor. Now our hub rotor has two different sides that we will have adapters for. The back side right here, and of course your front side. Now inside is typically grease, so you want to make sure you clean that grease out, make sure you get all that as clean as possible. The next step is to find the right side adapters. Now all the adapters are back here, and you just basically pick and choose the one you think is going to fit the best, and the one that fits the best is what falls inside the race. In this case, when you look on the inside, the race is actually that shiny part right around here. So we'll pick the adapter we think will fit the best. This one is way too small. However, this size fits right in there. So we'll kind of put this one off to the side. We'll turn this around. And we want an adapter that's going to fit on the inside as well. Inside this race right here. Okay, on the outside hub bearing race. A little side note, these races are replaceable. However, most of the time you just buy a new rotor if possible. Now all we have to do is mount this to the machine. Okay, now we need to actually mount the rotor to the machine. The first piece we need is our hub bearing, the very first one we picked that goes on the inside, the larger one. And that adapter for your hub bearing will slide right there. Then you'll need your rotor. And then we'll need the smaller one. Your spacers. Now if you notice, I have a very large gap right there with 2 spacers on. So I'm going to need a 3rd spacer for this one. There we go. I'll of course get my silencer band on. Almost ready to cut. Now I need to go ahead and adjust my cutters to center onto this rotor. I'll take my wrench. And now, just like before on the hubless rotor, I'll set the machine up the same way. I'll cut out the ridges, go inside, do my cuts, do my finishing, and then I'm done. And this is all you have to do for a hubbed rotor if you're to machine it. Now, the next thing we're going to cover are drums. Drums set up a lot like a hubless rotor, but the machining is actually on the inside. So first thing we need to do is actually set this on top of our chuck to set on the machine. So I'll actually take my drum, set on top, secure and tighten. Now my machine's set up for a rotor. I want to go ahead and set it up for a drum. I'll loosen this up, pull up my pin, go ahead and remove my rotor blades. Now I have free access to my blade that's right here for my drum. Now my drum needs an inside cage. I need a cage that's small enough to fit on the inside and also not so big that it'll actually prevent my blade from cutting into it. So the cage I got is this one right here. I'll go in. Remember, I always pick up by the actual chuck, never by the drum or rotor. All right. I need my 2 spacers. And I have a little bit of thread showing. That's good enough for me to use just my nut right here. Now, this belt is actually used to silence a drum. It just fits on here and stretches. And as you put this on here, it'll wrap around a few times. Okay, now let's start with the cutting. Now remember about my speed. Okay, same thing goes for a drum. When you're practicing, you want to go on fastest cut always. But on a customer vehicle, on your last true cut that you'll use for a customer vehicle, you always want to go to your slowest cut as possible. For this exercise, we're going to stay on fast, since we've already been through a slow cut before. We're cutting with the blade right in here. It's kind of hard to see, but you'll see it here in a second. Now, first thing is I have to bring in the blade. This back handle actually brings the blade out. Go ahead and bring in my blade more against the machine. Now this machine is not exactly going to cut yet. I'm just going to turn it on like I did before. Now I just want to bring the blade out. I'll slowly move the blade against the drum. And just like before, I'll cut my outside lip, then I'll go into my inside of my drum and cut that lip out as well. Right there, I'll stop. I'll go ahead and move my blade out. And now all I have to do, move this to drum. Now since the machine has stopped cutting, we go ahead and move this over to the off position. Go ahead and turn it off and inspect your work. You may have to machine again or until all of the old surface is completely machined off. Now on a drum, you typically don't have to sand the inside, however you can if you want a better finish. Now you want to go ahead and dismount our drum. Always carry it by the chuck. If you have any grease or anything else left here, make sure you wipe it down. As well as clean up your area that you have. You may notice now we have a lot of shavings around here that are need to be go ahead and get cleaned off. Go ahead and take our cutting heads for our rotor, put them back on. And then we can go ahead and take our drum. The shavings out of there, and now we can inspect it and see if we need to cut more. If we're happy with it, and ready to turn in for a grade. This concludes our demonstration of how to machine rotors, both hub and hubless, and drums. This Hunter BL505 machine can actually machine a little bit more than that, including flywheels and such. However, in the automotive shop setting, the primary purpose for this machine is for rotors and drums. If you have any questions, please let me know. Feel free to ask or also view other resources we have online for you. Thank you very much.